Hello, everyone. This is Xi Xiao. This is a new episode of Salesforce Web Podcast. Today, I have a new guest with me. His name is Christian Warden. Hello, Christian.
Hi, Sheath. Thanks for having me.
Yeah, I love your last name, by the way. It's like from the games.
Thanks. My son plays baseball, and they always call him Warden out on the field. I like it.
Yeah. It's really matching the theme. So, Christian, would you like to quickly introduce yourself?
Yeah, sure. My name is Christian Warden. I've been developing on the Salesforce platform since 2008, so almost close to 20 years now. Before that, I was doing web development since about 2000. And I started my career as a Unix administrator. And so I've kind of been doing a mixture of development work and systems work, and it's kind of overlapped in doing development tools. So that's something I've enjoyed doing as I've been building applications, is building the tooling to help build those applications and get them deployed. And I've continued that into my Salesforce career.
Yeah, thanks a lot. We in the past exchanged some idea because both of us did a bit the Apex language parser thing, right? You build it on Golang, I built it on Rust. We exchanged the idea how we did it briefly, and then after that, I think you took a far further away like step in addition to just the parser. So you built this new tool. So how to pronounce this new tool? R or
so I pronounce it Air.
Air?
It's spelled
Okay.
AER.
AER.
In the US, the only time you really see that is maybe with Aer Lingus, the airline.
Okay.
So if you pronounce it Air, maybe with a little Irish accent. But most people have been pronouncing it AER, and I'm okay with that too. So
Okay. Yeah. That was the tool actually really fall into my radar when it was published in LinkedIn. I think some of my technical bodies like Anthony Heber and Scott Wells also, they did like the internal kind of like beta testing with the tool. Is
Yeah,
it so?
yeah, Anthony's been one of the earliest testers when it was barely functional. He was telling me, I need to try this. I need this for my software development. So he's been a great resource in testing.
He's a fantastic buddy indeed. Yeah, the thing is that tool triggers me because the idea behind is that you can run the Apex tests locally. Maybe you have some other features on the tool. We're going to discuss that later. But only like this one to me is like, wow, that's the thing I've been wished for so many years. I guess a lot of other developers also wished for such a thing because we all know Salesforce, it has to run either Scratchwork or Sandbox. It has to run on the cloud. And it's slow, right? No matter how fast you test is, whether it's unit test or integration test, it has to go to the cloud. That's like a multi-seconds at least. But run locally, it was like a dream because there were so many things like restricting it. You can't do this, you can't do that. And Salesforce was a black box. And since this tool really achieved that goal, isn't so?
Yeah, that's right. It's the pain that we've all felt as Salesforce developers is during development, as you're editing the code, you've got to deploy it to an org to test it and make sure that just to compile it, make sure that it compiles and then to actually execute it. And so during development, there's a lot of those round trips. So every day you're probably losing minutes at least, just kind of waiting. And then when it comes time to run your full test suite, you also have to deploy everything to a sandbox or a scratch org and run all of the tests. And that can also be very time consuming when you get a large test suite built up.
Yeah. So is that the biggest selling point for this tool? Or does the tool have some other features also helping us?
That was the main impetus for building it, was to solve that pain around having to deploy to an org during development and kind of in your CI environment, right? the other big feature that fell out of having a local runtime is that it has a debugger as well. So you can debug your Apex locally like you would any other language, really. That's something unusual with Apex, is that you don't have a normal local debugger you can use. Now you do. So you can step through your code, set breakpoints, inspect variables, and it'll follow through the triggers. And so it's great if you have a complex, you have a complex code base that you're trying to debug, or if you're new to an organization and there's a large existing code base and you just want to get familiar with it. I find that stepping through code, even if you're not really trying to find a bug, but just to understand how the code works, having a debugger is a nice way of kind of feeling your way through a code base that's new to you.
Wow, I didn't know that. I'm gonna definitely try it. But to me, is that the local environment already sounds really intriguing, because at the beginning I was wondering, hey, how it can be achieved locally. Then I spent a bit of time to really dig into this tool. It's an open source tool, right? All the things
No.
I can open the box a bit.
It's not an open source.
Okay.
It's a commercial tool. There's a kind of free tier that you can download it. Everyone can download it and start using it. You can run your tests against your code base. If you run more than 100 tests at a time, it requires a license. And you can test out the debugger, but the debugger is also really a commercial feature. So after 5 minutes of debugging, you'll also need to purchase a license.
I think that's fair. With so much amount of work you have put into this, it's definitely there. But would you mind to at least tell us from the concept level how this local runtime and the database, like DML, SQL queries, how you have achieved it? I think that's really the interesting part, if you don't mind.
Sure. Yeah, like you mentioned, it kind of started with Apex Format, which was the Apex code formatter that I built a number of years ago. And so that gave me a parser to start from. And
the code format, that's similar to because in Salesforce, people usually use the de facto, what is it?
Prettier,
the Prettier,
is
right?
The common one, yeah.
The Dalmar created that Prettier one. So, the one you created is similar to that.
In many ways, I mean, it takes your Apex and it formats it. It's an opinionated formatter, though. So it's based on the idea of Go format, which is there's only one format you can't configure whether you want spaces or tabs, or whether braces should be on their own line or not. It's an opinionated formatter. So everybody that uses it gets code that's going to look the same. And it's not as fast as your formatter, I know, but it's based on the Antler grammar that came out of there's a tool called toolingforce.com, which was used to as the basis for a VIM plugin that's been around for a long time, 15 plus years, I'm sure. And so that grammar's kind of evolved, and it's splintered, or it's not really splintered, but it's also shared by some other tools that use that same Antler grammar or derivative of that original Antler grammar for some Java tools and some JavaScript tools. So like I said, so it started with having a parsed Apex tree. And a couple years ago, I read a book called Writing an Interpreter in Go by Thorsten Ball. And I'd never written an interpreter or a compiler. I've never taken a class in it. But I found this book was very well written and gave me the idea, well, maybe I can write an interpreter for Apex now that I've got somewhere to start from. And so I basically used some of the ideas from that book to say, okay, I've got this parse tree. I need to now create an AST out of it. and then I'll start executing that tree. And so that's what it started with.
Mm-hmm.
And then that allows you to execute kind of the most basic Apex. But there's a lot of features in Apex, including all of the DML features. And so I did introduce a database. So it uses an embedded SQLite database in memory. And basically, when you run AAR with your tests, first it's going to parse the metadata that's in your repo, and so it'll build a database based on the schema from that metadata, and it'll parse the Apex and build a parse tree, and it's going to essentially execute that Apex, stepping through it all and performing all of the database operations against that local database.
Okay. Let me try to repeat if I understand. So the Apex, somehow there is this parser. It can translate the code into a so-called AST tree. And with that AST tree, you can somehow map it to the Golang. Is that how you did it?
The engine is written in Go, and it essentially walks that tree and executes the statements that are in that tree. So we translate the Apex into this tree structure, which has things like method calls and constructor calls and all of the different operators, things like that. And then the interpreter written in Go executes that tree.
Okay. So once the Apex code logic translates to the AST or the abstract tree, then it's language agnostic already. Then you can use that AST tree then to map it to the Golang. For example, if it's an if-else condition in Apex, and you can map it to the if-else if the Golang has, I assume it has. So it's kind of like a one-to-one map. If it's assignment logic, then it will map to the assignment. Is it like kind of like one-to-one translation?
It's not getting translated to Go, but the interpreter is written in Go. So we've got this big tree that's structured as structs in Go, and so there would be a conditional node in that tree for your if or if else statement, and when it sees one of those, then it would execute the condition and evaluate whether the conditions are true, and it would descend through if the condition is nested or there are if it needs to evaluate the condition by calling a method, for example, it would do that, and then eventually get the result of the condition, and then it determines whether to go down the path of the true condition or the false condition. And
I also have bookmarked a book for the interpreter. It's not for Golang, but I had it in my like a bookmark. But then when the AI era hits, then I kind of like shift my time to the AI tooling learning. So I didn't have the chance to really learn that. Maybe one day I could put more effort on that, then I could fully understand what you say. But I more or less get the idea. You also mentioned that based on the local pulled from the org, the metadata for the data model, like the object fields we pulled in as a source format to our local, then your tool could set up a local database, simulate the data model for that. Is that
that's
the case?
Correct. And it tries to follow the structure that is exposed by Salesforce. So an object.
Is it the same database, like an Oracle database I assume Salesforce is using, or do you use some other rational database?
It's using SQLite as the database.
Okay. So then there must be some challenges when you do the translation.
There are, because SQLite doesn't have all of the features of Oracle, And so there have
Okay.
been different obstacles to overcome to get it working for sure.
Yeah.
But the idea is that there's one table for each
Okay.
object. And so it at least looks this kind of what you would expect a database schema to look like.
Mm-hmm.
If you're looking at an object in Salesforce with its fields, they map pretty directly to what's created in the SQLite database.
Okay. I think I now have at least more or less a naive picture in my head. So it tries to simulate the Apex runtime locally with this Golang interpreter, and then when when the execution hits the DML or SQL query, then it run against this local database, right? And especially when we run the tests, mainly the test is like setup, and then setup, especially in the database, some configurations, and then to assert if finally the record has the correct data in the database. That's typically how a test with the DMLs that happens. And now we can fully run it locally, right?
Right.
That's how it does.
Yeah. So when you get to a DML statement in the code, or you get to a SQL query in the code, then that gets translated into the database query.
Wow. I mean, it sounds simple, right?
Conceptually, it is simple. In practice, it's very complicated.
Yeah. I mean, I just think about you use a SQLite to simulate the Oracle database. I can't imagine like how many edge cases you hit. You have to pull your hair out to really figure out the good ways. So I can't really imagine.
Like I said, I had some early users who were providing feedback on running the code against their code bases. There are also a number of open source Apex repositories that I was able to use to test against, which helped me identify many of those edge cases that weren't handled early on.
Okay, yeah. But other than these challenges, there are also surrounding metadata in Salesforce. So they're not just Apex, right? We have validation rules. We have, flows especially, right? They are part of the orgs. So how do you slice that carefully just to make sure it really works?
Yeah, so in addition to there being an Apex engine, there's also a formula evaluation engine, essentially, which is simpler than the Apex. Salesforce formulas aren't as complicated. And I'd actually done some work on, similar to Apex format, parsing Apex. I've built a library called SFormula for parsing and formatting formulas, Salesforce formulas. So that's also something that I could build on top of in building Air, was I had this at least parser for the formulas. And so that parses validation rule formulas, formulas in flows, formulas in Visualforce are also pretty similar. So I'm able to use kind of the same code there. So in addition to evaluating Apex, we also have to evaluate formula fields and validation rules. And there are really two implementations of like formula fields, both kind of in memory and a translation to SQL, so that when you're querying formula fields, the formula actually gets translated to SQL to get the data out of the database.
Wow. Yeah, I almost forgot the formula part. And you like digged into this rabbit hole and expanded this thing under the ground. Okay. But how, I mean, that's already part of your solution, right? So you mean
That's
this
right.
Air tool supports formula field, which is already a big achievement. But how about the validation rules? Those things, are they outside of your tool? We're not supposed to have it in the scope.
No, validation rules are supported as well. So as you're executing the code, if there are validation rules found in the repo, they all get loaded and they all get evaluated when you're doing DML to determine if they fire or not, and you get back the same errors that you would on Salesforce's implementation of Apex. And,
Okay. So you mean if I pull those validation rules to the local, then they are included. When I run the test will actually call those validation rules. Somehow you can simulate that as well.
That's right. Yeah. So when it loads in the metadata for the objects, if it finds validation rules as well in the repo where you're loading your sources from, those get loaded into the schema that's used during execution. And so it checks to see if you're doing DML on an account, are there any account validation rules that need to be executed? And if so, it'll evaluate those.
How about flow?
So flows as well. There's a flow engine built into it.
Okay.
So
please continue.
It finds flows. So it will parse the flows that it finds in your repo and it loads all the sources. And flows are actually kind of easy in that they're already structured as a tree in the XML. So the parsing, anyways, is relatively straightforward. And Air will actually translate the parsed flow into the same AST structure as the Apex so that it can then execute the flow the same way it would as if it were written in Apex.
That's interesting.
So
I think only when you really dig into that and start implementing, then you will see this. I was treated like a black box. I never really wanted to see what's going on there.
The structure is a little bit ugly in the XML, but if you parse it and just separate out all the XML tags, it's pretty clean to look at.
Okay, that's interesting. Okay. But how about, I don't know, are there other metadata also supported? I understand the more you support it, of course, the scope is bigger, but it's more mature or more well-rounded your solution is, right? Comparing to the Salesforce org.
The goal is to support all Apex that runs on Salesforce's platform. So if you have tests that run on Salesforce's platform, they should run in Air as well. And there are still some edge cases, probably in some of there are some open bugs on some of the more esoteric namespaces that I'm still working on. But in general, it should all work. So in addition to the Flow runtime, there's also a Visualforce engine, a partial Visualforce engine. There's not yet a feature to render Visualforce pages. I haven't found a need for one, but you might have Apex that sends Visualforce emails. And so in order to generate those emails, you need to be able to parse parse Visualforce and execute the Visualforce expressions. And so it will load in any Visualforce pages. It will load in your email templates, Visualforce components. And so if you send an email from Apex using a Visualforce template, it will take that email, it'll find the email template and load in the corresponding Visualforce component and evaluate the expressions using the defined Apex controller if there is one. So all of that's also built in.
Wow. It's already a big map for me, like back when Salesforce introduced the source format, there was a table, right? Map from the metadata format to the source format. So for each type of the metadata, I know, is it supported in the source format or not? I think for your tool, maybe it's also good if we can have like a one-to-one map so we know what are already supported. I see it's like such a big scope already you have, but I'm still missing like what things are not possible even technically on your end to support it to run locally, like asynchronous Apex and, for example, governor limits, all those things. I guess it's not easy to be done.
They weren't easy, but they are implemented. So there's
You're killing me, Chris. Okay, okay, wow.
Yes. So asynchronous Apex will work in your test the same way as you'd expect, where they run upon stop test.
Mhm.
What else? Sorry, what else did you mention besides asynchronous Apex? Oh, governor limits.
Uh, Governor
So
limits, yeah.
governor limits also it'll track your DML calls, your SOQL queries, the number of rows that are queried, and it even will try to track your CPU usage. And that's a bit tricky because we're not running on the same execution engine or the same hardware, but basically benchmark against how different operations work on the Salesforce platform to try to have your code fail at the same time or roughly the same time that it would if it were running on Salesforce's platform.
Wow. I don't know what to say, but it's such a big achievement. You really went so far after the discussion we had last time. But I would assume there are a lot of companies really are interested in this, and especially for the engineers, like the senior engineers, that they really write the code in the like they really require fast feedback loop, right? They really want to run it locally. Then it brings such a big benefit. But to me, it's like if one day I want to acquire or to buy the license, I still want to know what things our code can do or cannot do. For example, I have run your tool against like a solution that I have in my work. Like it has 100 unit tests, like 60 of them, like 60 of them actually pass, and 40, I think majority of the failed 40 is just because some Apex are not pulled to the local because there are too many dependencies on some other files I don't want to do. But only the minority of the tests actually failed, and fired some bugs. You fix them. So it seems to be really easy to get into this, but still I'm missing like what it cannot do on my end. I don't know if that would be a good README section.
So that is one of the obstacles that people can run into is that there are implicit dependencies in their code base um, that they just don't really know about or they haven't had to deal with yet because
Right.
they're always running it against their
The org.
either production
Yeah.
org or a sandbox. And so
Yeah.
you do need to make those explicit by pulling in making sure that all of your code is in the repo. And any metadata that needs to be there in order for the Apex to run successfully, you'll need to pull in as well. It tries to give you some helpful errors. If things are missing, it can't resolve something. If you want to just kind of get past those to try it out, there's an option to skip errors. So if you wanted to just ignore those cases to get started, you could skip those ones that have dependencies on code that's not in the repo yet. The other thing that you may run into challenges with is with managed packages. So if you have dependencies on managed packages, there is, well, basically third-party managed packages where you don't have the code for it, right? You've installed the package in your org. There is a command to create mocks for those packages from your org. And so it'll fetch the metadata that's associated with that package namespace from an org, and it will fetch the stubs that Salesforce creates for the global classes and methods and create a file, I call it package file, that you can load when you're running your tests. So it'll make available those things that are in the namespace of the managed package to your code base. And if your code just depends on the metadata within a package, that may work right out of the box. Like you run this package mock command, and you'll be able to run your code using that package. If you have dependencies on calling methods within managed package code, you may need to actually mock those methods. So there's a command to edit those stubs that get created, and you can have it return some mock data.
Okay, so you have two levels of mock, right? If you are really calling into the method of the managed package, which to us is also a black box, you just know the signature, you don't know the details of implementation. For those things, you can also run a command in your tool to mock the data. But under the hood, it's just a static text result you try to swap with basically without really calling the real method, you just return the mock data.
When you're editing it, you're editing Apex, so you can have that mock method be as simple or as complex as you need it. So, for example, I worked on a project that used Accounting Seed, and there are some methods in Accounting Seed to like finalize transactions. Accounting Seed is an accounting package that runs on the Salesforce platform, and there are some methods that our tests used to finalize or post a transaction, basically. And so when we call that method, if our code assumes that calling that method results in DML happening, you can perform that DML in the code. If you don't really care what the side effects are of calling the code, but you expect it to return some value, you can have it return just some stub, mocked value that is always the same.
Okay. So your tool tries to facilitate as much as possible, even if it's a black box, right?
It tries to let you at least work around that black box.
Right.
And how challenging it is depends on how much your code depends on the side effects of calling into that black box.
Right. Okay. I also, when I run this tool, I see there are some other features. For example, I saw that it can serve as a Salesforce work for other applications that depend on the Salesforce work to call this local environment. For example, like if I have a website that always calls Salesforce API to get the sales related data, then this Salesforce org actually is like a backend of that website. And here, that website now can use your local runtime or this tool to serve instead of calling a real Salesforce org. Is that also a feature?
Yeah, so there's a server command. So AER server will start up a server, which acts like the Salesforce API endpoint. And you can run the Salesforce CLI to log into it. Then you can use the REST API, the bulk API. It doesn't support all of the API endpoints yet, but the goal is to allow you to treat it as if you were talking to a Salesforce org. So you can, if you wanted to run your tests through the API rather than using the test command, you could do that. And if you were developing an application that uses Salesforce as the backend, you could be developing those both offline. You can be having a test against your local Salesforce org that AIR is simulating for you.
Wow, that's really cool. How about the data in this local org? Can it be persistent, or is it each time when I spin up the server command, is it fresh?
There is a flag to the server command to use a local database file, a SQLite database file. And so it could be persisted to that database. I haven't come across a use case yet where that's used a lot. And it's not meant to be a production environment. It's not meant to replace a Salesforce org. It's meant to be a developer's tool while you're developing. So you're not going to want to hit that server talking to the local SQLite database, with hundreds of concurrent connections. You're not going to get
Right.
Salesforce level performance out of it. But for doing local development, you could persist the data to a database. There is also a flag called Bootstrap DB, so -- Bootstrap DB, which can be used both with the server and with the test command to load in some data into that ephemeral database whenever it runs. And so that's useful if you have things that in your database or in your Salesforce org that can't be represented by metadata. For example, org-wide email addresses. If you have tests that depend on them existing, you can load them in from a SQLite database from the org-wide email address database or table. Or if you have something specific in or you want to have some users, for example, that already exist, you can create those in a SQLite database and use that Bootstrap flag to load that data into the database.
Wow, that's really amazing. It blew me out of the water. I don't know what to say, but it's such a wonderful tool. For the engineers, this is really amazing. What's the roadmap for this tool? What do you wish it in the future?
So first, I just want it to be able to run every Apex method that's out there. Mm-hmm. I want to make sure that it works kind of perfectly as you'd expect. So the first version 1.0 just came out a little over maybe 2 weeks ago, I think. And a lot of the main focus was getting all of the code that I found, either my code that I've worked on in different projects or open source projects or some of the early testers, getting all of that code to work. I've been working on more enhancements to flag errors before you get to Salesforce. So now code that wouldn't work in a Salesforce org to make sure it doesn't work in air as well. So you get the same kind of errors. So you're not writing code locally and you don't find out that it doesn't actually pass when you get to deploying it. So there are more of those kind of edge cases that I'm finding and fixing because the initial scope was getting as much code as I could to run. So now I'm finding the cases where code that shouldn't run in there. But basically want to track Salesforce's updates. So 3 times a year, the plan is to release updates so that you're able to keep using all of the new features that Salesforce releases in Air and develop keep your code up to date and track the latest API versions.
Yeah, I almost forget this. 3 times release a year. That's a lot of work to catch up if it's like a major release. Like last time I discussed with Andrew Fawcett about the version 67, right? It's a big security shift. I guess that also must be causing some challenges on your side to update to align with that version too.
Yeah, so an early version of the application didn't even track the API version of the Apex, but I started identifying cases where behavior changed between API versions. And so now when it loads in Apex files or triggers, it also tracks the API version and it handles those API version specific changes. And so, yeah, if you load in 67 code, you now get the default user mode changes.
Wow.
They're just
okay. I don't know what you're doing now, but it's like what? it's like impossible for I don't know. Is this tool like so far is built by you, like one person, or is it like a team?
So far, I've been the only one working on it. So my company, October Swimmer, is primarily or has been primarily a custom development shop. And so that's really what we've been doing. I've been building tools as well for a long time, but the bulk of the business has been in custom development. And so I took a step back from that last year to focus on building this application. And so I've just been heads down working on getting this application built and tested and getting it out.
So you mean you only spent a year, you achieved so much?
There are some pieces that, like I said, I built on top of the parser
Right.
for
Mm-hmm.
Apex and the parser for formulas. And I had actually started working on a Flow runtime a couple years ago for a different reason, really, to solve the problem of doing code reviews on flow changes is very painful when it's just
All
like
right.
a bunch of XMLs changed. So I started building a local flow runtime that would allow you to check out the branch for a pull request and kind of execute the flow locally. Um, and so I don't know if any of that code survived, but some of the
Mm.
ideas, anyways, made it into Air.
Wow.
But
That's
the bulk of it's been since the start of 2025. Yeah.
yeah. Okay. What I can say is I really appreciate your effort. I couldn't imagine that it can go this far. I mean, it was a dream for a lot of people, but when we see, hey, Salesforce is such a monolithic org. Apex is just part of it. It's kind of like tangled inside it, like interweaved inside. It's really hard to slice it out. It's almost impossible. But you have achieved almost this impossible mission is already done. Uh, yeah, but they really blow me out. If I may ask, what was the biggest challenge along your journey? I think that's only the author can say.
There have definitely been some of those Apex quirks that I've run into that have had me stumped for a bit. There are things like mutable keys in maps behave very weird in Apex. So if you use like a custom class as the key, um, working with those maps, you'll get weird results. Things like when you call values or when you call key set on the map, you start getting back to different values than you did before you called it. There's some when you call into or you try to get like a field from an S object that hasn't been set. There's some weirdness where if that S object is in a wrap-in class, like a custom Apex class, it behaves differently. Um, the fact that there are two default namespaces, system and schema, and they behave differently for different classes. So there are classes like location, address, site that exist both in the system and the schema namespaces. And if you instantiate a location without the namespace, you're going to get the system location. But if you instantiate a site without a namespace, you get the schema site instead. So some of those little quirks for sure. The different the API version issues. There's like unreachable return statements behave differently. At some point, they changed.
Right. But I can totally understand that with the Apex language, which is a full-fledged language, and it has so many versions along the history. So there must be a lot of edge cases like a normal developer never need to pay attention to or even never noticed. But until people like you to creating the tooling, then you start to find out, okay, there are all these things you need to cover. I think like you or Scott Wells, who created the Illuminate Cloud plugin, these people just start to really dig into those things.
Yeah,
Right.
Scott's actually been very helpful as well because
Mm.
early on he built an integration of Air into Illuminated Cloud, and
Okay.
in doing so, he was able to use his existing test suite that he's built up to test Air as well. So he reported a number of bugs and weird edge cases, So I'm glad that Scott's been
Uh,
an early adopter as well.
yeah, really glad to hear that you both are collaborating there too. Okay. Mm. So before we leave, do you have anything you still want to add?
Um, you kind of asked about future goals or direction.
Yeah, yeah, yeah.
One thing I haven't mentioned is that there's also a WebAssembly version. So you can run the VS Code extension in the browser. And so if you use github.dev, you can run Apex completely, not just locally, but locally in your browser. The
Mm-hmm.
performance isn't going to be as good as running it on natively on Linux or Mac OS or Windows. But it is possible for you to step through code in your debugger or run all of your Apex tests in the browser. And with the new web console, I'm trying to encourage them to support extensions, which would allow using Air within the new Salesforce Web Console because it is a version of VS Code, of the VS Code Web. And so um, I was able to get it working in kind of in development mode where I could load Air into the web console, but until they officially support extensions, it's not really possible. But I think that's kind of an interesting idea. Is you'll not just be able to view your Apex directly from an org, but execute it, step through it, debug it.
Yeah, I think I forgot to ask you about this local debugger you mentioned at the very beginning. I think that's circling back, which is also good. So, uh, because Salesforce has this replay feature, right? It can lock all the Apex finest lock into your local, then it kind of like replay on that lock information. Then you can stop at some point. But on your end, because it's local org, so you can determine it's like a real local stopper here, right? You can set the points and break it there when you execute. But now you set VS Code has this web version which do not run it in your local. I think that has been a feature for many years already. But Salesforce start to use that for the Salesforce development, and your assembly version can be a plugin on that. Is that what you're trying to achieve?
So there's an Air VS Code extension, which you can install in normal VS Code on your desktop.
Mm-hmm. Okay.
But VS Code also supports web extensions, which is it's an extension that doesn't require any uh, local execution on your computer. Just it runs entirely in the browser. And
Ah,
so
okay.
when you use there's vscode.dev and there's github.dev, which is another version of the VS Code web version. That it will support the Air extension, and it will load a WebAssembly version of Air. So instead, Air is compiled to Linux
WebAssembly. Mm.
on ARM and AMD 64 and Mac OS and Windows, but it's also compiled to WebAssembly and will run in the browser using the VS Code extension.
That's a really neat feature. I guess Golang natively support this. If you can compile to a binary with some limited plugins, then you can easily translate into a WebAssembly. Is it so?
So Go has WebAssembly as a target, so you can
Right.
compile to WebAssembly.
Oh, that's wonderful. Okay, I'm gonna give it a try maybe later. Okay.
It's cool to see. I mean, it's probably not going
Yeah.
to be your daily use because, like I said, the performance isn't going to be as good. It's single threaded, whereas the native version will use all of your CPU cores if it can try to use as much memory as it can to run your tests as fast as possible.
Right.
The WebAssembly version is not going to be as performant.
Okay. Cool. I guess we have covered a lot about the tool, and I get really impressed by your tool. I would say this is probably the number one tool I discussed so far. It's such a vast scope, and you have achieved it. Really, congratulations to your
Thank you.
achievement. So I will put your LinkedIn this tool GitHub link, and also your company octoberswimmer.com, is it? So all this link, I will put it on our show notes. I appreciate your effort again, and thanks a lot, Chris. Maybe we can chat next time.
Thanks, Xi. It's great talking to you.
Yeah. Bye-bye, Chris.
Bye now.